Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Physics Paper 2 Higher Tier from 2025. Question number 9 is on the topic of magnetism and electromagnetism. Transformers are used to change alternating potential differences. Figure 11 shows a transformer. So what you're seeing is a step-up transformer because there's more coils on the output. Why is the core of the transformer made from iron? Now, iron can easily be magnetized and demagnetized. A transformer has 345 turns on the primary coil, 6,000 turns on the secondary coil. The potential difference across the secondary coil is 400 kilovolts. Calculate the potential difference across the primary coil. Use the physics equation sheet. So let's convert this. You don't really have to, but because you'll get the answer in kilovolts, which you'll have to convert it later, but they want the answer in volts. So this will be 400,000 volts. So the equation is voltage on the primary coil divided by the voltage in the secondary coil is equal to a number of turns in the primary coil divided by the number of turns, not V, it's N, number of turns in the secondary coil. So substituting it, voltage in the primary coil, which is what we are trying to find, divided by 400,000 is equal to the number of turns in the primary coil is 345 divided by number of turns in the secondary coil is 6,000. Rearranging it, voltage in the primary coil is equal to I could actually do this value, which will be 345 divided by 6,000 is actually 0.0575 and multiply that by 400,000, which would give me 23,000. Now if you didn't do the conversion for the voltage, you'll get it the answer as 23 volts, and then you can multiply it by 1,000. The answer is 23,000. There is an alternating current in the primary coil of a transformer. Explain why there is an alternating potential difference across the ends of the secondary coil in the transformer. Now, if there is an alternating current in here, that produces a magnetic field in this coil, which is also changing directions. As the magnetic field changes direction, this coil is also within that same magnetic field because the magnetic field passes along the iron core, which, because this coil is in an AC current or alternating magnetic field, it will produce an alternating AC current on the output as well. So the AC in the primary causes a changing magnetic field in the core. The secondary coil cuts through the changing magnetic field, inducing a potential difference across the ends of the coil. That brings us to the end of this question and to the end of this paper. Thanks for watching. Hopefully you find it useful. If you did, subscribe to the channel so you can get more help for physics and biology papers as well. Thanks for watching. Bye for now.